Hey 7th graders, so by now you should have gone over the notes on how to do Punnett squares and the notes over monohybrid crosses. You should have also done the Punnett square worksheet, so that will definitely help you with today's assignment. If you haven't done those two things, you definitely need to go do them, especially the notes from earlier this week over Punnett squares and monohybrid crosses, because this is really not going to make a ton of sense without those. Okay, with that being said, your assignment today is called Monohybrid Basics Worksheet. It is due tomorrow. And your learning targets are, I can correctly use a Punnett square to predict the genotypic and phenotypic ratios of offspring. So this may not be exactly the genotypic or phenotypic ratio, but they all kind of center around that same concept. Okay, so obviously you found the video. And moving on to the first part. So there's 4 parts to this worksheet. First part is vocabulary. Okay, for this one's fairly simple. You guys can just click and type. So directions, match the words in the word bank with the correct definition. So here's your word bank. We have alleles, genotype, recessive, homozygous, dominant, phenotype, and heterozygous. Okay, so these should be in your notes, so make sure you use them. But basically you have like genotypes made of the same allele. The answer to that one would be homozygous. Because remember, homo means the same, so if 2 parents pass down the exact same thing, maybe it's 2 dominant alleles or 2 recessive alleles, that would be what we call homozygous. Okay? Moving on. This is also vocab related. So basically you guys are given a term. In this case, number 8 is dominant allele. And you guys will use your draw tool to circle the correct answer here. So you guys remember can click and change colors. So anything that is a dominant allele in this little area here, you're going to either want to circle or highlight. Maybe I use my highlighter. Okay. So dominant is uppercase letter. So anything that is an uppercase letter, we would highlight. So we've got big D, big L, big N, big R, and big S. Okay. Let's look at some of these maybe down here. So genotypes in which the dominant allele will show up in the phenotype. So remember that if one of the parents, even just one, it doesn't have to be both, passes down the dominant allele or a capital letter, that individual will have the dominant phenotype. So in this case right here, big A, both parents pass down the dominant genotype or allele, so that parent or that offspring would have a dominant phenotype. This one we've got big D, little d. So one parent passed down the dominant trait, so therefore that offspring will be dominant for that phenotype. Big E is dominant for both, big J, big R, and big S. So basically the only one we didn't highlight is little f is because you have 2 copies of the recessive trait. So go ahead and finish 9, 10, 11, and 13. Okay, remember anytime you use the draw tool to make sure you go back and click the cursor. Okay, moving on, you have some specific colors that you need to use. So directions, of the 5 Punnett squares below, highlight the ones that are filled out correctly using green. So we're not talking about the whole Punnett square, but we're just talking about the individual boxes. So if they're correct, we're going to use green. And if they're incorrect, we are going to use purple. So if we look at this one, this parent passed down a big D and a little d, so that one's correct. This one, little d, that's correct. This one is big D, little d, that's correct. And this one is little d, that is that's also correct. Okay. Moving on, we might see something that's incorrect. So let me find one for you guys. So this one right here. Okay, this parent passed down a big D, this parent passed down a little d. So this one is incorrect. Okay. Same with those 2 are right. Never mind, sorry. So that one is the only one that's correct. So the other ones I would highlight green. Okay. So again, we're looking at just the individual boxes inside. So you guys should see some that maybe are all correct or all wrong. You might see some that are partially correct and partially wrong, like this one here. Okay. Moving on, back to my cursor. Okay, part 2 is more Punnett squares. So these are just 2 little quick answers. So if we look back, what do the letters on the outside of the Punnett square represent? So these letters right here and right here. So what do they represent? And then what do the letters on the inside represent? So those are your two questions to answer on the next slide for Punnett squares. Okay, and then moving on to part 3 is your monohybrid crosses. So this one is where you guys are actually going to be solving some of these monohybrid crosses. So I'm going to go over the first one with you guys and do the whole thing for you, and then the rest should be ready for you guys to go. So in guinea pigs, brown fur B is dominant over white fur little b. So your trait being studied in this is you're going to kind of just sum up those things. So you have brown and white fur. We're going to go ahead and call this fur color. Okay, so type in fur color. And then you have your little allele key. So it says brown fur big B is dominant over white fur. So you're going to make a little key right here and say, all right, our dominant allele is big B, and that means brown fur. Okay, your recessive allele is the lowercase b, which means you guys have white fur. Okay, so that's our allele key. So that's how you guys would answer that question. And again, I'll keep these on the worksheet for you guys. Then it goes ahead and goes to the question. The other ones are structured a little bit differently, but I wanted to break this one up for you guys. So it says the mother guinea pig has the genotype big B, and the father has the genotype big B, little b. What is the probability that the offspring will look like the mother? So let's just go ahead and address this first part right here. Okay. The mother guinea pig has the genotype big B, and the father has the genotype big B, little b. So we're going to go ahead and talk about the genotypes. This one's pretty straightforward for you guys because I just give them to you. So mom's genotype, big B. Dad's genotype is heterozygous or big B, little b. So mom, homozygous dominant, homo again means the same. So you have two dominant alleles passed down. Okay, versus heterozygous means a mix. There is no heterozygous dominant or heterozygous recessive. Remember, because you have that capital letter, that dominant allele, it's always going to be dominant. Okay, so just heterozygous. There's no dominant or recessive following. All right, so then your next step is to go up here and you're going to fill out this Punnett square. So step 4 is the Punnett square. So let's go ahead and start with mom. Again, it really doesn't matter what mom passes down and what dad passes down. Or excuse me, where you guys put the mother's alleles and the father's alleles. So let's just go ahead and say, all right, mom can either pass down a big B or a big B. So we're going to put the big B here and another big B here. Okay, versus dad can either pass down a big B or a little b. Okay, so we'll put him across the top. Again, it doesn't matter if you put mom on the top or dad on the top or whoever on the side, it's fine. Okay, and then go ahead and fill out your Punnett square. So this one is big B, big B, big B, little b, big B, and big B, little b. Okay? And then now we can focus, once our Punnett square is done, we can focus on the actual question. So the question asks us, what is the probability, so we're looking for either a fraction or percent, that the offspring will look like the mother? Okay? So again, if we look at this, mom is big B. She has brown fur. So we're going to look at all of these offspring here that have a capital B in it, which it happens to be all of them. So your answer would either be 100%, or you guys could say it 4 out of 4. Okay, so any of those are options for you guys. You guys, again, could either do it as a percent or a fraction. Okay, so that's the answer to that question. The next one I want to just kind of touch on it with you guys, that I'm not going to leave the answers in this one. So hopefully, if you guys are watching this, you have 2 of these done for you guys. The hornless trait in cattle, capital H, is dominant over the cattle with horns. A heterozygous hornless cow is mated with a homozygous horned cow. What will be the genotypic and phenotypic ratio of the offspring? So just take this one step at a time. So your trait study is horns, okay, whether you have them or you don't, okay? Your dominant allele, so then you can go up and say, all right, capital H is hornless, lowercase h is horned, and say, all right, mom's genotype. Now let's start to get into it. So it says a heterozygous hornless cow is mated with a homozygous horned cow. It doesn't tell us mom and dad, so really it does not matter, okay? So we do know that we have a heterozygous hornless cow. So that individual, whether it be mom or dad, is going to be big H, little h. Again, it doesn't matter which parent is which. Okay, versus the other parent is a homozygous horned. So if we look here, we see that horned is little h. And if it's homozygous, remember homo means the same. So it's going to have two little h's. So I'm going to go little h. And then I can go ahead and fill out my Punnett square. Big H. Again, it doesn't matter which parent goes where. And then little h. So again, this parent can either pass down a big H or a little h. This one can either pass down a little h or a little h. So there's where I get my little outside grid parts, is from which alleles the parents could pass down. Go ahead and fill out the genotypes of the offspring. Okay, and then you guys can go ahead and interpret your questions. So really, it's just important that you guys take this one step at a time. Okay, what will be the genotypic and phenotypic ratio of the offspring? So we do this a little bit differently than we do percents. Okay, so let's talk about genotypic ratio. We're going to list all the different genotypes that we're going to see in those offspring and how many of each there are. So for instance, we see, let's do this one, a big H, little h, and another big H, little h. Okay, so 2 out of 4 of those have the genotype big H, little h. So for the genotypic ratio, we'd write 2 big H, little h, and then we do a little colon anytime we do a ratio. And then we look at our other genotype we have, little h, and 2 of the 4 are little h. So we would finish after the colon and say 2 little h. Okay, phenotypic ratio, same way, except you're looking for phenotypes. Okay, so if we look at this, remember that our capital H is hornless. So these two right here are going to be hornless because they have that dominant trait. So we would write 2 hornless. And again, that little colon, 2. And then it looks like our little h are going to be horned. So little h is horned. So we would go ahead and type that as well, to 2 horned. Okay, so those are your ratios, and that's how you type a ratio. So it needs to be in this colon form, and you need to basically list how many of each different type of genotype or phenotype there are in the offspring. Okay, so that's how you guys do those. I'm going to let you guys go ahead and do the next 3. So on the next one, you're looking at tomato fruit, so color of the fruit. You're looking at whether you can roll your tongue or not, so the ability to roll your tongue. And then eye color is going to be your last one, okay? So looks like these are all either probability. So you're looking at, again, percentage or fraction. So that was the only one you had to do genotype or phenotypic ratio for. Okay, finally, do your wrap up. Do you have any questions, yes or no? Obviously, if you have questions that are preventing you from finishing this assignment, make sure you let me know right away and I can help you out. And then 4, 3, 2, 1, how did you do on this assignment? Finally, you are all done. Here's a happy picture of me cuddling the unicorn I was riding in the first slide. Anyway, turn it in. I hope you're all having a great day. Bye.